let me just say, okay, I told you 2 axioms. There's a third axiom. Just so you'll have it down all at once. These are topos, which again, topos really means comparison of 2 topos. So one is, bonus not only exists, but preserves products. And another one was that going from points to, I put it in terms of the phi's or the p's, it's just a matter of, if that's epic, that's the Nullstellensatz. And the third one that I didn't mention at all yet is that for every object, there exists another object, the monomorphism, with the property that pi 0 or p lower sheet is 1. In other words, every object can be embedded into a connected object. That's clearly true for both kinds of graphs. You see, if you have any graph, well, you have some dots that aren't connected. You'll put some in. Just put some in, and you've got many ways to make it connected. But from that example, it seems like something almost trivial. But if you think instead of G sets for G a group, you can't count for G sets for G a group. There's only a finite number of connected things anyway. Namely, they correspond to stabilizer subgroups, which is subgroups of the group, so small in number, even though the character is big. So you couldn't possibly embed every G set in an orbit with the same G. So the character of it is totally different. You can't looking at the graphs, and it could be misleading in that way. It's a non-trivial property. It's trivial for them. It seems trivial for them. Now this can be put in various ways. It's equivalent in various things. But for one thing, you could take x tilde to be the particular functor which started me off on this whole thing, axiomatizing the topos in a finite number of axioms. Namely, this the partial map classifier. Partial map classifier is a specific monad on many topos that classifies partial maps. It sort of looks like this. You see, you have the object, but then you add to it some stuff. Well, down here is false. And from each point here, there's a copy of the truth value object. So whatever this was like, this result is connected. In fact, it's contracted. It's connected, at least because you can sort of, by just multiplying by truth values, you can decrease the domain of definition until it's not defined at all. So you tune the thing out of existence just by multiplying by a given truth value, by various truth values. You tune a given map is defined, a partial map is defined somewhere. You tune it. Now the tuning, this will make the whole thing connected if pi 0 of omega itself is connected. I mean, intuitively, right? If these lines are connected, then I made the whole thing connected because I can always go down and back. Well, that picture is slightly crude, but it's correct nonetheless. In fact, for the truth value to be connected is the same thing as this whole thing here. There exists some connected container of a very general existence, but that implies that omega itself is connected, and if omega is connected, in any case you always have this partial map classifier monad, and that will be connected as well. So you have a functorial. So the intuitive, I always think of it like this, that X might itself have been a disjoint union. In other words, you might have thought that the people on Mars and us are totally disconnected, but then you can make a bigger space, which involves more advanced technology. Now we're connecting it. Something like that. You can, things that you thought weren't connected, actually, if you change the object, they are. But you can't do that with G-cells. It's not. When you say it that way, it just sounds like one of those arbitrary things you can push around. No, depending on the nature of the category, you usually can't do it. Typically, you can't do it. For cohesive toposes, you can. So those are the three axioms. And now you know that, we can have a break.